SwayamPrabha. Digital India. Educated India.
Today we are going to start module 3. So, module 3 is about glass and ceramics. As you are students, you always see glass around you, and you all know it gives the transparency to a building, and you can see through it when you are inside. You know, mostly the application of glass we see on windows and sometimes on doors, and many other which we will expose to you one after other. But what is more difficult in glass is it is transparent, it connects you with the outdoor when you are indoor, at the same time it connects you to the indoor when you are outdoor. So, this is the beauty of glass, which is not in any other, you may say almost any other material. Now, this also gives it another difficulty is its brittleness. So, whenever we see a glass item, we always know we have to handle it with care because it is brittle and it may break. So, any kind of uneven treatment to the surface of glass may make it break. Other than any other impact, it will always break. We also have, along with glass, we will discuss ceramics, particularly ceramic tiles, which we use on floors as well as walls. So, it is having a coat of glass that gives it the ceramic property, and the beauty of glass and ceramics is they are very much inert towards chemical action. So, we can use glass, particularly in its specific uses are there, and we have to take care of this brittleness factor whenever we are putting glass. In particular cases, we have to be very careful so that it gets a longer life. Similarly, ceramics we will have particular applications, and where it is required mostly in clinical environments, chemical environments, biologically safe environments, there we will find most use of ceramics. Other than that, we have our ceramic tiles which has replaced stone, marble, granite, we may replace it with ceramics, and we also have a higher version of it, the vitrified tiles. So, we will come to first glass, where we will cover a small introduction, steps of its manufacturing, and also the ingredients for its manufacturing, the properties of glass, and also a list of different types of glass, which we will elaborate it in our next lecture. So, coming to the introduction, if we go for what is glass, it is a supercooled liquid, it is amorphous in form. It does not form its crystal, it does not get the formation, but even then it is random and tightly packed atoms, and that structure makes it brittle. So, it can break because the bonding as a crystalline structure does not take place, and it is homogeneous in texture. As I told you, it is transparent. So, any kind of impurity in it would be visible. So, if there is an air bubble entrapped while the glass is being made, then it will be visible. If a small particle, maybe a small stone particle or any foreign particle or metallic particle remains embedded in it, will be visible by naked eyes. So, One is you have to get it clean, clear. Another is it is perfectly flat expected. If you hold a glass piece horizontally and you look at it at its horizon, you may find it is little wavy. So, when someone is on the other side, it may not give a right image. So, glass may be little wavy, that also can be tested. So, we see glass in architecture, if we say, we will see mostly in three areas. One as glass in the facades, glass as a construction material, and glass in insulation. So, glass in facades is particularly, you see it is in the building fenestration, that is the doors and the windows, and also the claddings in facades. There may be glass walls where glasses are fixed one with the other and it creates the glass facade. On the other hand, we can see glass as a partition wall. Glass may come in blocks also. Skylights, so there may be a roof, there may be a large space which has a roof. So, to that enclosed space you need to give some light, some atrium has some high top roof from where you can actually pour in light by treating it with glass. So, the solar rays can filter into that space. We can have glass floors, we can see what is happening below by walking through it. This gives a sense of transparency and you can feel like what is happening below can be seen. Glass as a construction material, we can have glass staircases, it gives a very transparent look. So, these are the areas where glass can be used, but I have told you in by very initial beginning that glass is brittle. So, obviously, there should be different kinds of glass or maybe differently treated glass that will help in developing such qualities like taking loads, or maybe it will not break or it may not be dangerous or unsafe when it breaks. So, we have to know how those are achieved and where to propose which kind of glass, because with all those special qualities adds up the price. Now, glass in insulation, we have glass wool, which are threads or strands of glass which are used as insulators. We will discuss on that little later. So, you see the use of glass for viewing. We all know window, it is crystal clear, you can see the outside mountains from the inside. We can use glass as a shelf. You can see such shelves in shops, in showrooms, even in small grocery shops. There is a glass top where the display, you can see what is below it, the display is better. So, the shopkeeper puts glass as the top on which he actually displays his items. At the same time, you can see what is inside. You can have glass as a guard wall. So, instead of having a conventional railing, you can create a transparent wall through which one can see what is happening below. So, it is guarding, no one is pushing it, but at the same time if something hits on it, it will not fall or break. We can see strengthened glass through a mesh inside the glass. So, this gives reinforcement to the glass. So, if this breaks, then also there will be a certain characteristic. So, we will come to that later. You can see entire glass and steel structure in front of Louvre Museum. This is also a display of glass. We come to see glass facades without frame, glass facade with frame. So, glass has been put inside a framing system. In the picture here, you can strongly see the strong frames lines of which a portion of it is openable. Here you see, you do not see the frame. You can see glass fiber as reinforcement in some corrugated item. These fine strands which you can see inside it are all glass fibers. So, these have strengthened this corrugated surface. It may be in plastic, you get glass fiber reinforced plastic. So, we can use glass in different ways and all have the purpose of its use in buildings. So, we have to know them one by one, but before knowing them we should know, okay, here is another picture of glass fiber being pushed in a wall for insulation. You can see some woolly material pushed in. As you see, the person is wearing thick gloves and even his eye is also protected, which is not visible, with a proper helmet. So, it is so soft, woolly, cotton like item, then why is he wearing these? It is glass. That is why he need to protect himself. Even there should be a mask, because these thin strands of glass may be inhaled also. So, let us see the stages of manufacturing and what are the ingredients that make this totally transparent material. The stages of manufacturing are: one is melting, then is forming, and then is finishing. So, these are the basic three stages. So, melting is melting of the ingredients in their given proportions when mixed with water and heated in a furnace. So, lot of bubbles come out and gradually it converts into something very fluid in nature. As you can see, something is coming out in the picture. Now, after that is the stage of forming and shaping. So, it will be a viscous material which will be coming out, and then at a temperature of 800 degrees centigrade, you see a number of ways you can form it. One is by blowing, one is by flat drawing, next is compression molding, then is spinning to get fibers, another is annealing to get different strengths. So, if we see one by one, in blowing you can get desired shape and the glass has to be allowed to cool in that particular shape, and then that becomes the item of the specific shape. What we are interested in is flat. As you see, mostly it is used in flat as a flat surface. So, we need to flat draw and get it in sheet form. Now, how big, how long we can use, how long we can have a glass sheet? As I told you, it is brittle, we cannot go for very large sizes, and again there are limitations of making it. At the same time, the point of brittleness. So, we have to know that sheet can be flat drawn by rollers, and you will get something 3 meters by 4.5 meters of running length, and you have to allow it to cool to get the flat drawn sheet. Compression molding is you are putting the molten glass into molds and you are allowing it to cool down and you get the desired shape according to the mold. Spinning is again another way where we get glass fibers, and annealing helps it to get different strengths. So, annealing is a process of slow cooling of formed glass, again reheated, and you are going for slow cooling, and then you get different strengths of it. You can achieve higher strengths of it. And after doing all these operations the way you want it, mostly it is flat drawn, and for fibers we are going for spinning, and we have annealing to get another set of glass, strengthened glass. Once we get these, we go for the finishing, which is cleaning, polishing, cutting. So, you have to clean the surface, even if required polish it, and finally cut it to get sharp edges. If you see a glass piece in the cross section, you will see it is light greenish in color, slight green in color. It is because of the iron oxide in it. So, with addition of this iron oxide is coming naturally, that gives it that greenish tint, greenish color. But you can also add mineral oxides or metal oxides to get different colors. So, we will come to all those at the end of almost at the end of this lecture. So, let us see what are the ingredients that make glass. Already we have covered brick, we have seen porcelain, the player is sand, it is again sand here, and you have soda or potash and limestone. You add some broken glass in the furnace which is called cullet, and it acts as a flux. It brings down the temperature. Flux prevents loss of alkaline compounds by volatilization. Now this sand, soda, potash, limestone and this cullet, these are all finely ground, and this entire mix is called batch, which is mixed it with water and heated to a temperature of 1000 to 1200 degrees centigrade. Carbonates of sodium and potassium are added to it, which reduces the melting point of silica. So, the melting point of silica comes down from 1700 degrees centigrade to 1000 degrees centigrade. So, this reduces the furnace temperature. So, you add carbonates of sodium and potassium to get such energy saving. It makes the liquid silica more workable and viscous. So, because you have to draw it, it has to be workable and its viscosity should be maintained. You see, here are the functions of soda, potash, oxides of iron, coloring agents, where you see soda is the accelerator of fusion for fusion of glass, potash makes it resistant to fire, even borax makes it resistant to fire. We know borosilica, so borax and silica, that makes it fire resistant. So, by adding oxide of iron, oxide of lead, you can change hardness, you can change brilliance, you can change color. Brilliance as in glass which are made for manufacturing lights, which is not our domain. So, we can use lead to make it more brilliant. So, the brilliance increases by adding lead. Coming to the coloring agents, they may be different metal oxides, as I told you, to give a different total set of colors. So, we will come to that later, what color is obtained from which metal oxide. So, borax increases heat resistance, lead gives shine, iron oxide gives strength, and this is how glass is being made with its specific ingredients. So, you can change ingredients to some extent to get different properties, different characteristics, and that will give you a different kind of glass. So, let us come to the properties of glass. As I told you, glass is transparent, thin as compared to other building materials. So, now as it is thin, you also need to know its thermal property. It is brittle due to its amorphous structure, that also I discussed. It is not affected by ordinary chemicals, reagents, air and water. So, it is impervious. It does not allow air and water to pass through it, and it is not affected by acids. Yes, affected by alkalis to some extent, but not at all affected by acids. So, this is a very good item non-reactive item which is to be used in laboratories, used in medical hospital areas, pathological laboratory, chemistry laboratory, biological laboratory. It does not absorb any kind of microbes, so it gives stain free, completely clean, clear surface. Its hardness, reflective power, all can be altered by treatment. So, reflective power means it will reflect out the light, it will transmit some portion of light. So, we will go into those when we go into the different types of glass. Glass can absorb, refract, transmit light and also reflect light as required. Its specific gravity is 2.5. Coming to its mechanical property, you see the tensile strength is 30 to 60 Newton per millimeter square. That of glass fiber is much higher, 700 Newton per millimeter square. Compressive strength is 700 to 1000 Newton per millimeter square. So, you can understand that yes, glass can have good mechanical properties. Coming to thermal properties, you see the U value of glass is 1.05 watt per meter degree Kelvin and it varies from 0.8 to even 1.25. So, I am giving you the average value of it, and you see parallelly the glass wool is much reduced value. It is 0.04 watt per meter Kelvin. So, in glass form actually glass wool form, it is actually giving a lot of insulation. Now, we come to the workability of glass. Can we work on glass similar to that of wood? Can we cut it? Can we weld it like other metals? Yes. Can we cut it? Yes, you can cut it into desired sizes. Can we drill it? Drill some hole in it? Yes, we can, but not for all types of glass. Related to welding, we must be very careful, glass being brittle and the temperature through which the temperature transition, glass transition, you need to cool it very slowly because welding operation there is a temperature gain in the local area where it is being welded. So, when you are welding two glass pieces, a local heat is generated in the central part where you are joining. So, you cannot go for very sudden cooling. If you go for very sudden cooling, it will lead to cracks. Same is for drilling. When you are drilling glass, you have to remember that you cannot treat it like drilling through wood or drilling through brick because it is a fragile or brittle item. So, you have to be particularly cautious to know the ways actually the workman actually knows, but yes, you can weld glass, you can cut glass into your desired sizes, you can drill glass. So, these three things which one needs to do it in building while you are using is to be known to you as would be architects. Let us come to another property, the solar heat gain coefficient or SHGC of glass, which is also called as G value. It is the transmitted solar radiation through the wall, through the glass surface and the incident solar radiation onto it. So, if there is a window with one glass pane, the transmitted solar energy inside the building divided by the total energy incident on it is the G value of it. So, obviously, it is a ratio and it is obviously between 0 to 1. If the glass transmits the entire energy, then the whole thing will go to 1, and if it is checking or not allowing the radiation to permeate get inside the building, then actually you can get a better control of the solar energy. So, higher the value, more is the solar energy transmitted within the building through the window. So, reflection, absorption, transmission, these three factors affect this solar heat gain coefficient. In cold countries, one looks for higher G value. For hot areas, we want to cut it down. So, we will look for most of it should go out. So, transmitted solar energy should be lower of the incident solar energy. So, this also is the particular quality of glass when it is in a glazing system. We get different kinds of solar heat gain coefficient. We will come to this part later on. Now, let us look into the different types of glass, which we will elaborate mostly in the next lecture. We have sheet glass, plate glass, float glass. We have colored glass, which I have already told you. Translucent glass, ground glass, frosted glass, obscure glass, these are almost same kind of items. We have tinted glass and laminated glass. We have reinforced wired glass. We have tempered glass. We have switchable smart glass, and we have hydrophilic and hydrophobic glass. So, you can understand that it is not one type of glass being used for a particular building. For different types of building with different purposes, we actually can use so many types of glass, which we will elaborate in our next lecture. Thank you.